Alright, boys and girls, welcome back to the drive-thru for a special parent-teacher conference version of the drive-thru. This edition is brought to you by artists. All those people out there that are putting their pens on their papers and making drawings. This one's for you. This one's for you, Avant. Okay, so in order to do these these proofs without pictures, it's helpful for you to first write this thing, at least write it in your head as an if-then statement. So what this is saying is that if an isosceles triangle has a median drawn to the base, then that median bisects the vertex angle. Well, now that we wrote it in if-then form, it's much easier for us to figure out what we were given and what we need to prove. Okay? The next thing I need to do is draw a triangle. I had this great idea that I would call this triangle, I got to draw a median, Paul. I just had that idea. Okay? There it is. Now, let's list out our given, and then we'll mark our triangle. So what are we given? Triangle PAL is isosceles with P as the vertex angle. You could have also said with side PA congruent to PL. That would have been okay. Okay? And I also know that PU is a median. It's a median. It is not an altitude. Well, it is an altitude, but we don't know that it's an altitude. We haven't proven that it's an altitude, so we can't use it like it's an altitude. We can only use it as a median. Okay, now what is a median? A median bisects the opposite side. It's a segment that starts at a vertex and travels to the midpoint of the other side. So, now I can say that AU is congruent to LU, or UL. And that would be definition of median. Okay, now I'll say that PA is congruent to PL, and my reason for that is definition of isosceles. Notice I was given here that it was isosceles, so I can use that here. Okay? So now I've got to pick. And from here, this is where I'm one of the few types of math teachers that have to grade your tests like an English paper. Because some of you are thinking angle A is congruent to angle L. That's great. And some of you are thinking PU is congruent to itself. That's great too. So some of you are going to prove this using side angle side, and some of you are going to prove it using side side side, and there's no one way that's better than the other. Okay? So I'll use, I think I'm going to use side side side. PU is congruent to PU by reflexive. And the reason that I'm using side 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 is because it reminds me of a snake. And then that reminds me of my friend Snake, who I love. So this one's going out to you, Snake. Alright, so now I can say that triangle PAU is congruent to triangle PLU by SSS, also known as the snake theorem, from here on out at least. Okay, so we want to prove that the median bisects the vertex angle. Now be careful here. Many of you guys think that you're one step away, and you're not. You're 2 steps away from here. So now you'll say that angle APU, APU, is congruent to angle LPU by CPCTC. And finally, I can say that PU bisects angle APL, and my reason will be definition of bisects. Can I get a second bell boom?